Ever feel that shift? One day your head's down, coding, and the next, your team starts looking at you, asking, which path should we take? This one or that one? That's when it hit me. I wasn't just writing code anymore. I was making architectural decisions. It's a huge transition, moving from being an individual contributor to someone who shapes the very foundation of a system. Suddenly, the weight of choosing technologies, frameworks, and approaches lands squarely on your shoulders. It's not just about picking the coolest new tech. It's about deeply understanding how each choice will ripple through the entire system, affecting everything from performance to future maintenance. Making these choices is a heavy responsibility. You're not just deciding on a database or a programming language. You're deciding on the future trajectory of the product. Will this technology scale? Is it secure? Can we find developers who know it? Will it lock us into a vendor we can't escape? Every decision carries long-term consequences, and the pressure to get it right is immense. It's a bit like being a city planner. You don't just place a single building. You have to think about the roads, the plumbing, the power grid, and how it will all function together 10, 20 years from now. That's the true weight of architectural responsibility. It's about foresight and accountability. To really get a handle on this, I started thinking about it like a logistics company. Imagine you need to move goods from a factory to a customer. Technology selection is like choosing your mode of transport. To use a truck, a train, or a plane. A truck is flexible and great for last-mile delivery, but it's slow for long distances. A train is efficient for bulk transport over land, but it's stuck on its tracks. A plane is incredibly fast but expensive and can't carry as much bulk. There's no single best option. Your choice depends entirely on your specific needs. Are you shipping fresh flowers that need to arrive overnight? Or are you shipping tons of coal where cost is the main driver? This is exactly like choosing between, say, a monolithic architecture and microservices or SQL versus NoSQL. Each has its own strengths and weaknesses. Following this metaphor, every architectural decision becomes a balancing act. It's about weighing trade-offs. You're constantly juggling cost, speed, and reliability. Do you want it fast and cheap? It probably won't be reliable. Want it fast and reliable? Get ready to pay a high price. Want it cheap and reliable? It's going to be slow. This is the classic project management triangle, and it applies perfectly to software architecture. When we choose a technology, we are implicitly accepting its trade-offs. Opting for a managed cloud service might be faster to implement, but costs more in the long run. Building it yourself gives you more control but requires more development time and maintenance overhead. The architect's job is to understand these trade-offs and make a conscious, deliberate choice that best serves the business goals. So, where does architecture fit into all this? If technology is the vehicle and the decisions are the trade-offs, then architecture is the entire rulebook for the transportation network. It defines the system. The architecture dictates things like what kinds of roads can trucks drive on? What are the standard container sizes for trains? What are the communication protocols between the airport and the ground crew? It sets the standards, the principles, and the constraints for the entire system. It's the master plan that ensures all the different parts, the trucks, trains, and planes, can work together coherently to deliver goods effectively. In software, this means defining API standards, data formats, communication patterns, and security policies. The architecture provides the blueprint that allows many developers, working on different parts of the system, to build something that functions as a unified whole. This brings me to the core insight I've gained on this journey. Architecture isn't about creating fancy diagrams in UML or Visio to hang on a wall. Those are just artifacts, a way to communicate the plan. Real architecture is the practice of making accountable choices under a set of constraints. It's about being able to stand in front of your team, your boss, or even the CEO and clearly explain why you made a certain decision. Why did we choose Kubernetes? Why did we go with GraphQL instead of REST? The answer can't just be because it's cool. It has to be a reasoned argument based on the trade-offs. We just talked about cost, speed, reliability, and how they align with the business's needs. You have to be able to say, we chose this path because it gives us the development speed we need right now. And we are accepting the technical debt that comes with it, with a plan to address it in 6 months. It's about being accountable for the outcome. If your choice leads to a system that's constantly crashing or impossible to update, that's on you. But if it leads to a robust, scalable platform that enables the business to thrive, that's your victory. This is the fundamental shift from just doing things to defining the rules for how things are done. As a developer, your focus is on building a feature correctly. As an architect, your focus is on ensuring that all features, present and future, can be built and integrated in a way that is sustainable and effective. You move from being a player on the field to being the coach who designs the plays. It's less about your individual contribution and more about enabling the entire team to be successful. Now here's where it gets even more interesting. As your system grows and becomes more successful, you will inevitably face a new challenge. Distribution. It's not a matter of if, but when your single monolithic application, your one big train network, starts to creak under the load. You realize you need to break it apart to keep moving forward. You start thinking about service decomposition, breaking your monolith into smaller, independent services. But this introduces a whole new world of complexity. Suddenly, instead of one big codebase, you have 10 or 100. You have an explosion of new interfaces. How do these services talk to each other? How do you manage different versions of services running at the same time? Welcome to version hell. What happens when one service fails? How do you prevent it from bringing down the entire system? This move towards a distributed system is the next chapter in the architectural journey, and it's a big one. So to wrap up, the journey into architecture begins when you start making decisions that affect more than just your own code. It's about understanding the weight of technology choices and mastering the art of the trade-off, constantly balancing competing constraints like speed, cost, and reliability. Your role shifts from writing code to defining the rules of the game, making accountable choices that you can clearly explain and defend. But just as you get comfortable with that role, the ground shifts again. Success breeds complexity, and the lure of distributed systems becomes impossible to ignore. How do you navigate the chaos of service decomposition, interface management, and ensuring resilience in a world where everything is connected, but nothing is guaranteed? That's the challenge we'll explore next time. Thanks for watching, and if this resonated with you, be sure to like and subscribe for more on the art of software architecture. See you in the next one.